6.4.1d. The fruit tree yield per tree in an orchard containing 50 trees is 210 pounds per tree each year. Due to crowding, the yield decreases by 3 pounds per tree for every additional tree planted. What is the yield per tree that will maximize the yield for the entire orchard? Note, assume we are not going to remove any already planted trees, and it does have 3 ends there. Anyway, so we're not going to chop down any trees. All right, so I need an expression that is going to represent the yield for the entire orchard. Now, if we were to try to do it at this moment in time, we would say 50 times 210, and that would give us our yield. So we're going to take that same approach, but we are planting trees. I don't know how many trees, so I recommend that you assign a variable to the number of trees you're going to plant. Often we use x for the unknown, so I'm calling x the number of trees we're planting. That would mean that we now have 50 plus x trees. So the total number of trees that we have is 50 plus x. The yield is 210 currently, but every time we plant a tree, it reduces by 3 pounds. So that's going to be a yield of 210 minus 3x. So the total yield for the whole orchard is going to be our number of trees times the yield per tree. The number of trees, 50 plus x, times the yield per tree. Now we'll be doing a derivative of this and setting that derivative to 0. If you would prefer to do a product rule for your derivative, you certainly can. But I chose to multiply this out. So I did the 50 times 210, and I got 10,500. The outer, which is 50 times negative 3x, negative 150x. The inner, which is x times 210, 210x. And the last, x times a negative 3x, which is negative 3x squared. Okay, and then I put that into the order we are used to, which is the descending order. So negative 3x squared, and then the 210x minus 150x was 60x, and then I put the constant term last. That was how they conditioned us back in Algebra 1, right? So now when I go to take my derivative, I can do the power rule all the way across, and I don't have to do a product rule. Negative 3x squared has a derivative of negative 6x, and then 60x has a derivative of 60. The derivative of the constant term is 0. All right, so next we want to set that equal to 0 to find our critical points. And you can see this algebra shakes out pretty quickly. You would just move the 60 over. You could move the 6x over if you want to think of it that way. Either way, we're just going to get that x is 10. So we're planting 10 trees. If it had come up with a negative value for x, that's where we refer back to this note that says we are not going to chop down trees. That would not be smart. All right, so this is a positive value for x, so we are going to plant 10 trees. What did the question ask me? It asked me, what is the yield per tree that's going to give us this maximum? Now, they could have asked us how many trees we're going to have, and that would have been 50 plus 10, so we would have answered 60 trees. Or, in this one, they ask us, what's the yield per tree? All right, our yield was 210 minus 3x. And since we got x was 10, we just plug in a 10 there and get 210 minus 3 times 10, and that is 180. So this one is going to be choice C.